Well, as you can see, we've got our square back again. And this time I want to bisect the base. So I'll take my compass and swing an arc below and above from both sides. And we'll connect the intersections and get ourselves a bisector of the base. So, with a little bit of luck, we will go from here through to here and find that that right there would be the middle of the one side of the square. And from there, I'm going to try to swing an arc from this vertex down to this side. I want to extend this side so I can see it clearly as it extends. And let's see what we have here. I come across this way. I don't really know how long that's going to be, but I'm just going to guess it'll be over in here someplace. And eventually I'm going to want to come across and extend this side also. So while I'm in the business of extending these lines, I may as well go ahead and do it. Let's see here, right about like that, I believe. There we go. Alright, now for the fun stuff. We're going to start with the midpoint of this side of the square and extend it to that vertex up here. Right there. That's pretty close. Just a nudge more, I think. And that comes down here and hits right there. That's cool. What I want to do is make a rectangle over here, so I'm going to copy this side here from there to there. We're going to come up here and swing this. There. So if I connect these two, I'll have a rectangle. It's a very special rectangle. Remember what I did was I came across from here to here to get my original arc, like that. And if I look at that triangle for a second, I'll just call from here to here 1 unit. Here'd be another 1 over here. And since this is a square, the length of this side would be 2. And if you'll remember our trusty Pythagorean theorem, that is a squared plus b squared equals c squared, you've got 1 square plus 2 square. 1 squared would be 1, 2 squared would be 4, 1 plus 4 is 5, so this side here squared has to be 5, which means that this side here has to be the square root of 5 in its length. Now that doesn't work out too easily. It's going to be an irrational number, but we can just leave it like that for now. And if I were to go from here all the way over to here, I would come across from here 1, and then from there over to there would be square root of 5. So all the way across the bottom of this side would be 1 plus the square root of 5. And the side over here would match that one, that would be 2. Isn't this fascinating? Well, if I were to take and make a ratio of my long side to my short side, that would be 1 plus the square root of 5 to 2. How's that? Isn't that amazing? I wonder what's amazing about it. Well, let's see what we can do with this thing. Let's take the length of our side of the original square, or rectangle, they're both the same, and we will take this length of 2 here. You know, it's getting kind of crowded down here. I think I'm going to bring it up here so we're not so crowded. Okay, that's 2. I'm going to bring this around here like that and hit here like that. There we go, just like so. And if I were to come on down here this way, it would hit here. And if I were to connect across here from there up to here, I'd get another rectangle in there. Like so. Cool. Well, let's see here now. I wonder how long these sides are. This side here, of course, would be 2. This is 2. But this one here, across from there to there, what would that be now? This one here was 1 plus the square root of 5 all the way across. And this was 2 from here to here. So if I was to get this one here, it should be 1 plus the square root of 5 minus 2 to there. Now, isn't that interesting? I can simplify that. That would be negative 1 plus the square root of 5. Or square root of 5 minus 1 if you prefer. That would be the length from here to here. And that would be the short side of this rectangle, and this is the long side of it. And if I'm going to make a comparison of my long side to my short side, like I did before, that would be 2 over that. Let me see if I can find a place to work over here. It's going to be 2 over 1 plus 5, minus 1 plus the square root of 5. I guess that would be easier if we set it as the square root of 5 minus 1. That might feel a little bit more comfortable to us. Now this right here is not in simplified form. We don't like to have radicals in the denominator. And in order to get rid of that, what I have to do is I multiply this thing by something that will make the square root disappear. And it's ingenious. It's going to be the square root of 5 plus 1. And if I multiply that out, I find something interesting. I have to do the same thing top and bottom, of course. There. All right. For those of you who can FOIL that, your first two would be square root of 5 times square root of 5. That'd be 5. And the last two would be minus 1 times positive 1. That'd be minus 1. And guess what happens with these two? The outside 2 and the inside 2, minus square root of 5 on the inside plus the square root of 5 on the outside. They cancel each other out. It disappears. So this then is going to be equal to 2 times that, 2 times square root of 5 plus 2 over, I can simplify that, that's 4. So it's 2 square root of 5 plus 2 over 4. I suppose I could have left it in this shape. It would have been simpler, wouldn't it? Well, phooey. That's what happens when you're not thinking ahead. At any rate, I can simplify this one. Let me bring it back to where it was before. Let's bring this right all back here. We'll factor that 2 out of there. And that's 2 times the square root of 5 plus 1 over 4. And as you'll notice, these right here are both divisible by 2, so I can simplify it one more time. And guess what I end up with? I end up with 1 and the square root of 5 over 2. 1 plus square root of 5 over 2, which is an exact match of what we had before. It's the same ratio as the first original rectangle, which means that since these proportions of the large rectangle match the proportions of the small rectangle and all the angles match, the figures are similar and everything's proportional. Isn't that a serendipity for you? Now it's fascinating to notice we might be able to do this again. Okay, so let's see what I can do here. Suppose I was to take the compass again, and we're going to swing it again. Now let's see, where should we swing it from? We came here and we made a rectangle here, and I think I'm going to make a rectangle up here. So I'm going to go like this, from here to here, swing it over, like so, and I'm going to do the same thing again up here, like so, and I'll get another rectangle right up here. And guess what? This rectangle sides are going to be proportional to the other two rectangles. Like that. Isn't that something? It's absolutely amazing, isn't it? I wonder if I could do it again. Let's come from here, like this, and swing it down here, like that, and up here like this. Let's see if that's going to help us anything. Let's see here now. I think I've messed that up. I don't want it there. Let's come over here this way, like this. There we go. Let's see here now. Yeah, that's right. Yeah, right to here. And right to here. That's where I want that. And I get another rectangle over here, which is, guess what? Proportional to the other rectangles. This was discovered by the ancient Greeks, and it's called the golden rectangle, since it reproduces itself in many sizes and as you go on around. On and on and on and on. Let's do it one last time and we'll call it quits. Let's come from here across this way, here, like that, and we'll come up here like this, and over here this way. Uh-oh, come on, hold still. I'm having trouble with my compass again. You guys don't have problems with your hands, do you? There we go. And I can do it up here again. Another rectangle is absolutely similar. All the angles match, the sides are proportional. There, like that. Isn't that interesting? You know what we can do with this? We can take our compass and swing an arc across our square from here around to here. Just like this. Uh-oh, I missed it a little bit. Here goes human error again. There we go, that's better. Come on. Right to here. Come on, compass, hold together for me. Come on. As I bring that compass up, it stretches. There we come. That's better. Like that. So if I had a good compass, I would be able to get this arc right here. Okay? Make it darker so you can see it. Like that. And then I can do it over here on this square, this way. Come on now. Right to there, right to there. There we go. And I'll just trace that with my pen so you can see it better. Right around here this way. And one more up here. And guess what? I did that one in the wrong spot, didn't I? I think you can see what I should have done. Uh-oh, come on now, hold still. As it gets smaller and smaller, it's harder and harder to use the compass here. Right there. Bring it down this way, like this. Bring this arc up around like that, over to here. And if I had a square up there instead of a rectangle, I messed this up, didn't I? I should have a square here, like this. That's where that should be. It should be right there. So now I can bring this across my square up here, and so forth. And this continues on as fine as you can make it, okay? This is called a spiral, isn't it? In fact, this is known as the golden spiral, and it has the same proportions as the golden rectangle, and it's found in nature, in seashells and things of that nature. So that's our golden rectangle and our golden spiral, and there are the ratios of something called the golden section, which the whole thing is based on. It's absolutely amazing. We'll come right back to this in just a second in our next